All right, welcome to the study guide walkthrough for Unit 3, which was on similarity. And the first question has to do with the ratio between one triangle that is got sides of 5, 7, and 9, and another triangle that would be in the same proportion that has a perimeter of 357 feet. So this perimeter would be 357 feet. The other triangle has a perimeter of, well, let's add up, 9 plus 7 plus 5, and that is 21. So its perimeter is 21. So one way to think of this is what would be the scale factor between a perimeter of 21 and a perimeter of 357. So from 21 to 357, if I put that in the calculator and reduce it, or however you want to reduce it, I would get 1/17. So this means that this second bigger triangle is 17 times larger than the first one. So I need to take my sides and multiply each of them by 17 to get the same proportion but a perimeter of 357. Another way to work this would be to add up, say that 5 times a number plus 7 times a number plus 9 times a number should equal 357. And so then 21x equals 357, and x would then equal 17. And so you would plug that back in to get your 3 side measures. So these side measures, 9 times 17 is 153, and 7 times 17 is 119, and then 5 times 17 is 85. So the 3 of them added together would total the perimeter of 357. So kind of 2 angles you could take on that, 2 ways you could work that. All right, solve for x. We have a triangle that has been bisected by an angle bisector. So this is bisecting the angle, but not necessarily the side. So I'm going to say a ratio that x is to 9 as 16 is to 6. And I could cross multiply here, but when I have my x's up here all by itself, it's going to be easier for me to just multiply both sides by 9. And do that in my calculator. 16 times 9 divided by 6 is 24. So the value of x is 24. All right, now we have one of these proportional word problems. It's got it all set up for us. Basically, if you read through that, we've got 2 similar triangles because we have a right angle in common, and the other angles would be similar. So I'm just going to set up a proportion. X over 36 equals 5 over 10. I could do it that way. I could also do x over 5 equals 36 over 10, and you would get the same results. And this, I'll just solve this one because it seems easier off the top. I'm going to multiply both sides by 5 to get rid of the value there and get x by itself. So x equals 36 times 5 divided by 10, which when you put all that in, you've got 18. So the flagpole is 18 feet tall. All right, here we have a shape with parallel lines. So these are indicating that these are parallel, and that means that they should be, that AD and CE should be proportional, and DB and DE should be proportional. So if AD is 36, DB is 42, EB is 21, CE is, find CE, so that's our X variable. So we said you can go two ways, down the line or across the lane. So I'm going to start with my X in the top left. That just seems to be easier. I can do X over 21 equals 36 over 42. Or I could have said X over 36 equals 21 over 42. Either one is correct. I'm going to just multiply both sides by 21. Cross that out, and now I have X equals 36 times 21 divided by 42. And when you're done with that, it will come out to be 18. All right, determine if they are similar. All right, so I'm going to match up angles here. I can also match up smallest to smallest and so forth. So from one angle to two angles, I've got 20. From one angle to two markings, I have 12. So 20 goes with 12, should be proportional. Then I'm going to work my way around. 15 goes with 9. 20, 15, 24 goes with 14.4, and then 24 goes with 15. Nope. Fix that. 24, so we did 20, 15, 24, 25 goes with 12, 9, 14 and a half, 15. All right, so the next step, you want to reduce each of these fractions. So 20 over 12 comes out to be 1 2/3 if you put that in a calculator. 15 over 9 comes out to be the same thing. Same thing here and same thing here. So all the side measures are proportional, so we can say yes. And the reasoning would just be because all angles are congruent. All sides are proportional. Okay, and the similarity statement. So I'm going to start with, I can start with J. If I go J, K, L, M, working my way this way. Then I need to start with angle 1, Q, R, S, P. Similar to Q, R, S, P. All right, number 6. Oops, let me go over 2-page document. Indirect measurement. So this is a lighthouse problem. Cast 140-foot shadows. So here's my lighthouse, and it is casting a 140-foot shadow. A lamppost is 5.8 feet tall and has a 7-foot shadow. So we need to find the height of the lighthouse. The proportion would be x to 5.8 equals 140 to 7. So I'm going to multiply both sides by 5.8. And then x equals 140 times 5.8 divided by 7, which comes out to be 116 feet. And we might ask ourselves, does that make sense? It looks like a reasonable number, so we're going on. All right, this is a sample proof. We do need to make a change to the worksheet and call this triangle PON, because the other would not be correct. All right, the first statement, and that first statement is not in your word bank. It is always going to be given because they are giving you the statement right here. First statement is given. And then the next reason, we've got QMN congruent to OPN. And what we need to notice there is that this is a transversal. These are parallel lines. They are alternate interior angles. So alternate interior angles are congruent. Then the next idea would be that gives us one angle. Now, you could have done the vertical pairs, but they already put in the reason, so we're going to have to go with these two angles are also alternate interior. So that is angle MQN. See how they've named it. They went NQM and NOP. So this is the answer you want for that one. Okay. And then at the very end, we have a similarity statement. And again, we have to fix this because this needs to go like that. And the reason is because of angle-angle postulate. Right here. Okay, so let's look at it again. We were given a statement, then because we have parallel line markings, we can call that a transversal and get alternate interior angles on two different alternate interior angles, and then that gives us two angles and the angle-angle postulate. All right. Determine if the triangles are similar. All right, so it looks like potentially we would have side angle side. We just need to check out that our sides are proportional. So we've got 14 small side, small should match small. So I'm going to say 14 over 15 needs to equal 10 over 21. I'm going to reduce both of these and see what we get. Oh, I think I set it up wrong. 10 is the smaller. Yeah, I didn't do this right. My bad. So 10 over 15, small to small, should equal 14 over 21. Okay, let's reduce these. This is a 5 times 2 is 10. 5 times 3 is 15, so that's 5 and 5. 7 times 2 is 14. 7 times 3 is 21, so that is 2/3. 2/3 does equal 2/3, so the sides are proportional, and the angle between them is congruent, so we can say, yes, it is side angle side. And we need to write a similarity statement. So if we go from triangle TSU, then we need to be similar, and we need to name it based on the short side, going from PJM. All right. Now we need to go back to 9. Solve for x. All right, the difference here is we've got parallel markers, these lines are parallel, so that means we have proportional parts. So we need to find this distance here, which is quite simply 28 minus 8, so that's going to be 20 here. And then I can say that 3x minus 5 over 10, no, I'm sorry, good grief, over 20, 3x minus 5 over 20 equals 10 over 8. Okay? I'm going to just multiply by 20 and not cross multiply. So 3x minus 5 equals 10 times 20 divided by 8. So 3x minus 5 equals 200 divided by 8, which would be 25. Well, let me double check that. 200 divided by 8. That's 25. And then we're going to solve this, so add 5 to each side. So 3x equals 30. And then divide by 3. X equals 10. Okay? All right, the next one. We've got a map to scale. On these ones, let the units kind of guide you. So the scale of the map is inches to miles. So our scale is 0.5 inches to 15 miles. So that needs to equal 2.5 inches to how many miles? Okay? And if you kind of use your unit of measure, that'll kind of help guide you how that's supposed to be. So 0.5x equals 2.5 times 15. That is 37.5. Divide by 0.5. X is equal to 75. So the distance between the two cities would be 75 miles. Okay. Determine whether BC is parallel to DE. So if they are parallel, then the parts will be proportional. So we can say that AD and DB would be proportional to AE and EC. Okay, so you could set up this a couple different ways, but we'll just go with 15 over 10 equals 12 over 8. That should be equal. You can cross multiply to find out if it's equal. You can reduce the fraction. So I'm going to say that this is 5 times 3. This is 5 times 2. So 3 over 2, does that equal 12 over 8? Well, this is 4 times 3. This is 4 times 2. Reduce the 4s, and I get 3/2. So they are parallel because they are proportional. The parts are proportional. So we might say yes, BC is parallel to DE because, and then you could start naming all the things that are proportional because because proportional, I'll just keep it simple because proportional parts. All right, state whether the triangles are similar. If so, write a similarity statement and the postulate used. All right, the thing you want to notice here is nothing is marked to be parallel. So we can't go by that. We're going to need to treat this like two separate triangles with a congruent angle here. All right, so we've got the small triangle in red, and we will get a blue triangle here. Okay, so that's the two triangles that we're comparing. I'll go green for a while. Let's go green. All right, so that means that 6/3 should be proportional to the entire blue side, which would be 8/4. And we can reduce these. 3 goes into 6 2 times, 4 goes into 8 2 times, so they are proportional. And then what that gives us is the side. They are proportional by side, angle, side. All right, so we have multiple choice here. We're going to eliminate this one and this one. And OMN is similar to OJK. That is correct. And let's see why this one's wrong. OMN similar to JKO. It's the way the order that they named the angle in is no good. These triangles are similar. Solve for X. Okay. So once again, we don't have parallel markings. The whole distance, but so we're looking at small triangle, big triangle with a shared angle here. So 15 to 30 equals the whole distance of that other side is X over 30 plus 22, 55. All right. To solve this, I'm going to multiply both sides by 55. And then X equals, well, let me see. Let me get my calculator. Sorry. Well, 15 over 30 reduces to 1/2. So I'm going to go ahead and do that. 55 divided by 2 then. So X ends up being 27.5. Okay. All right, 15. Got to go up again. Is rectangle A similar to rectangle B? What is the scale factor as a reduced fraction? All right, well, we're just going to set up a proportion. So 24 to 20. Does that equal 12 to 10? All right, so choices, you can cross multiply. You can reduce the fractions. 24 over 20. So without a calculator, I would say, let's see, this is 5 times 4, so I need a factor of 4. So let's go with 6 times 4. 4's cancel, and now I have 6/5 and 12 over 10. This is 6 times 2, this is 5 times 2. So eliminate the 2's, and I get 6/5. So yes. The scale factor from A to B would be 6 over 5. And they are similar. All right, here's some dilation work. We've got the point, let me get it read back again. We've got the point 2, 2, which is L. We've got the point -1, 2, which is M. And we've got the point 0, -2, which is n. So we have this sort of a triangle. We want to have a dilation centered at 0, 0 with a factor of 4, scale factor of 4. So each point I'm going to make 4 times further away from the origin than when I started. So this point is at 2, 2. So 2, 2 times 4 would give me 8, 8. So this is much bigger. This color's not showing up great. Let me go with, this kind of purplish color. So we're going to go here. We'll call this L prime. M is at -1, 2. So I'm going to go times -1, 2 times 4 is -4, 8. So M goes -4 up to 8. And that is going to be M prime. And then N is at 0, -2 times 4 is going to give me 0, -8. And that's going to give me N prime. So I'm going to connect these. Attempt to. All right, so we have a similar shape. It is 4 times larger than the pre-image. And so that's looking good. And we are on the last one. All right. Another one with the center, the point at -10, 10, a point at 0, 5, and a point at -5, -5. And I should have labeled them. This is R, S, and T. And now we have a scale factor of 2/5, so this is going to be getting smaller. I'm going to have the point -10, 10 times 2/5. So 5 goes into 10 2 times, and then times 2 would give you -4, 4. 0, 5 times 2/5 would give you 0, 2. And then, -5, -5 would give me -2, -2. Okay, so those are my 3 new points. Let's go with -4, 4 is R prime. 0, 2 is S prime. And -2, -2 is T prime. So we're connecting here, here, here. I never connected the other one. So here to here to here. All right, looks a little funky, but it is the new image. The image is 2/5 the size of the pre-image, and they are proportional, so that's looking good. All right, I hope that helps, and just let me know if you have further questions, and we'll try to get to them. Talk to you later. Bye-bye.